I have a project with some simple code in it to demonstrate these operators. Now I don't have any classes in here. This is just some relatively artificial code just so that you can see how they all work, and hopefully none of them are any great surprise. I'm going to just run the project and show you the output next to the code that produced it. So we do a number of things to I and just keep printing it out. So we start out with I equal to 0, prints out as 0. Then we use the plus equal operator to add 2 to it, becomes 2. We use the times equal operator to multiply by 3, becomes 6. We use the minus equal operator to take 2 off of it, becomes 4. And we use the divide equal operator to divide it by 4, and it becomes 1. I don't have any demo of plus, minus, times, and divide, but I thought I'd show you these 4 convenience operators. Now let's scroll down a little and take a look at the increment and decrement behavior. You can see I'm using all 4 of them here. I'm going to start by setting j equal to I++. And then I print out I and j. Because I++ returns the old value, which is 1, j is 1, but I has been incremented to 2. When I go plus plus I, they both come out as 3. So the 2 is incremented to 3, and then that's what we return. J is equal to I minus minus, j stays at 3, and then I is decremented to 2. And finally, j minus minus I, the 2 gets decremented down to 1, and then they both get the value of 1. Those lines of code that we've just gone through, they're really artificial. Why would you write int I equals 2 and then add 3 to it or what have you? It doesn't mean anything. Here's an actual use of the increment operator, kind of semi-realistic. I'm going to run a loop. I'm going to start I equal 2 and go while it's less than 101 and have just a single line in my while, which is that I'm going to call is prime. And I'm going to call is prime with the current value of I, and then I'm going to increment I. So in this single line, I'm able to run around the loop from 2 up to 101. And I've taken this function is prime, which you may remember from other demos. It returns true or false whether the number is prime. And if it returns true, I'm using an immediate if, I'm going to add 1 to j. If it returns false, I'm going to add 0 to j. So I'm counting how many prime numbers there are between 2 and 100. 101 is not strictly less than 101, so we'll stop after we've processed 100. When this runs, it claims there are 25 primes, and you're welcome to count on your fingers and establish whether that's correct or not. The real purpose of the code is to show you an actual use for the increment operator, and for it being important whether I called I++ or plus I. If I were to call this with plus I, the first number that would get passed down to is prime would be 3, not 2, because we'd increment it and then call it. We'd actually get a different result when we ran this.